You've seen how we perform calculations using titration data and determining the concentration of an analyte. We can now formally write a general formula for an acid-base reaction that happens in a 1:1 ratio. So again, if the ratio or stoichiometric ratio is 1:1, meaning you have 1 mole of H plus coming from 1 mole of your acid, and you also have 1 mole of hydroxide ion coming from 1 mole of your base, then we have this formula. So molarity of acid times volume of acid solution is equal to the molarity of the basic solution times the volume of the basic solution. So regardless whether it is the acid that is your titrant or the other way around, you use this formula. Again, this is if you have 1 mole of hydrogen ion from 1 mole of your acid and 1 mole of hydroxide ion from 1 mole of your base. So if we look at the formula, we see that, or you know that, multiplying the molarity with the volume of the solution gives you what? The amount, right? Which is in moles. So what we are equating basically are moles of acid and moles of base. And this is aligned with our definition of titration. So recall that in titration, we stop adding the titrant when we reach stoichiometric equivalence. And the meaning of this stoichiometric equivalence, do you remember? It means that the moles, the amount of added titrant, is equivalent or equal to the amount of your analyte. That is why in our formula, we are equating the moles. Now, don't forget, this formula is if the reaction is 1:1. And I also have to mention that titration is not limited to acid-base titration. There are a lot of different types of titration, and it depends on the reaction taking place. If you are familiar with reduction oxidation reactions or redox reactions, we also have what we call redox titrations. So it's not limited to acid-base titration.